In the last part of section 4.3, we're going to look at curve sketching and concavity. So let's say we're given the following conditions and we're asked to draw a sketch that has these following conditions. Okay? Well, first of all, these first values given to us in A are really points. So we know that f of 0 equals f of 3 equals 0. So we know that at 0, we're at 0. And we know that at 3, we're at 0. And we're also told that f of -1 and f of 1 are both -2. So those are other points. Okay, and it also tells us, so we figured out or finished off the first set of requirements. We're also told that the derivative at -1 and 1 are 0. Okay, so if we make ourselves a little first derivative number line, okay, whoops, I don't want a pen. There we go, so this is f prime. I know that -1, the derivative is 0, and +1, the derivative is 0. And it says that the derivative is negative for when x is less than -1, so f prime is negative in this region, and between 0 and 1, it's also negative. So between 0 and 1, it's also negative. And it tells us the derivative is positive from -1 to 0. And it's also positive from 1 to infinity. So that means that I must have a maximum at 0, and I must have a minimum at -1 and 1 because my derivative is changing from negative to positive or positive to negative. And it tells me that the graph is continuous. So if I was to sketch this guy in, it's going to look something like it's going to come down, come up, come down, and then bounce back up here. So that would be one possible sketch following all the parameters laid out in this question. Okay, so there's going to be some questions for you to try, okay, and these ones are going to be part of your assignment, and you can check my answer key for these. So there's 43, 44, 45, 46, okay. Now in the next section here, we're going to look at curve sketching, and we're looking to find all of these requirements, and then we're asked to sketch the curve. So if we start here, the first thing I need to do for parts A and B, I'm looking for intervals of increase and decrease, is I need to take the first derivative. So my first derivative is going to be 6x squared minus 18x minus 108. And if I find my critical numbers, I'm going to factor a 6 out, okay? And if I factor a 6 out of 108, that is going to leave me with a -18. And I'm going to set my derivative to 0. So now I can factor quadratic. So therefore I get two possible critical numbers when x is 6 or when x is -3. So now I am going to do a number line test with my critical numbers of -3 and 6. Again, if I test a number to the left of -3, I use -4, a number in there would be 0 and 7. -4 will make both terms, both factors negative, times that positive is going to be positive. If I put a 0 in, I get a positive and a negative, and a 7, they're both positive. So in part A, to answer part A, I know that my function is increasing from -infinity to -3, also from 6 to infinity, and I know my function is decreasing with the derivative is negative, and that would be -3 to 6. So there's part A. Now part B, I can use my number line as well. If I want to find relative max and mins, I know that at -3 I get a relative max because my derivative is changing from negative to positive, and at 6 I'm getting a relative min. So I get a relative max at f of -3, which means I must plug -3 into the original equation. So it's going to be 2 times -3 cubed minus 9 times negative 3 squared minus 108 times negative 3 and plus 2. Okay, so now if I evaluate this all, I'm going to get negative 27 times 2 is going to be negative 54. This is going to be negative, this is going to be positive 9 times negative 9 is negative 81. This is going to be positive 324. And I have a plus 2. So therefore, negative 54 minus 81 plus 324 plus 2 gives me a y-coordinate of positive 192. And I get a relative min at f of 6, because that's where my derivative is going from negative to positive. So this would be 2 times 6 cubed minus 9 times 6 squared minus 108 times 6 plus 2. So this is going to be 432 when I cube 6 and times by 2 minus 324 minus 648 plus 2, so 432, take away 324, take away 648 plus 2. This ends up being negative 538. So these two coordinates are going to be on my graph. So I finished parts A and B by using the first derivative. Now in parts C and D, I want to do intervals of concavity and inflection points. So now I'm going to have to use the second derivative for part C. So I'm taking the derivative of the first derivative, so it's going to be 12x minus 18. And again, I'm going to set 12x minus 18 to 0. So I get 12x is equal to 18. And if I divide, I get 18 over 12, which reduces to 3 over 2. So now I'm going to use the second derivative number line test with 3 over 2. And if I plug 0 into the second derivative, which is right here, I'm going to get a negative. If I plug a 2 in, I'm going to get positive. So I know that my graph is concave up from 3 over 2 to 0, and it's concave down from 0 to 3 over 2. So in part B, that means my inflection point is going to be at 3 over 2. So it's going to be 2 times 3 over 2 cubed minus 9 times 3 over 2 squared minus 108 times 3 over 2 plus 2. And if I work this all out, okay, I'm going to get 7 over 8 when I cube this. 27 times 2 is going to be 54 over 8. This is going to be 9 over 4 times 9. It's going to be 81 over 4. 108 times 3 is going to be minus 324 over 2, which is going to be minus 162 plus 2. And if I work this all out and get a common denominator and find the final answer, I am going to get, I'll just work it out here quickly, ends up being negative 173.5. And that's going to be, if I write that as a fraction, it's going to be equal to negative 374 over 2. So now I have to draw my sketch. So again, we're just sketching this again. If you recall a little bit from pre-calc 30, I have a polynomial. That's a leading coefficient is positive. So I know it has to start somewhere in quadrant 3 and end in quadrant 1. And let's plot the points that I know. I know that negative 3, I'm at 192. So negative 3, I'm way up at 192. So there's the point, -3 and 192. And because I'm approximating it, it wouldn't hurt to label those points. And I have a minimum at 6 and -538. So 6 and -538. And my other point that I know is my inflection point, which is 1.5 and -173.5. So again, 3 over 2 and -374 over 2. Okay, so my graph is increasing until it hits here, then it's decreasing, and then it switches concavity right there and goes back up. So my sketch is going to look something like this. Again, this is an inflection point, so the concavity changes. This is a max, this is a min. And there's a graph that meets the requirements of this equation here. Okay, in our next question, this is a question actually off an AP exam. And we were asked to sketch a function based on this information, and it told me the function went from 1 to 4, so you can kind of see the markings here, 1, 2, 3, 4, and this graph was provided on the AP exam. Okay, so first of all, my function at 0 is -1, so I know that's a point on my graph, and that comes right from this guy right here. I also know that at 1 it's 0, so at 1 there's a point at 0. I also know that at 2, there's a point at 2, which is up there. At 3, I have a point at 0. Okay, and those are the 4 points that I know from my table. And I also know what's happening with the derivative. So it's telling me between 0 and 1, the derivative is positive. And that really means that my graph is increasing. And it's also increasing from 1 to 2. And it's decreasing from 2 to 3 and from 3 to 4. Now it tells me the graph of the derivative doesn't exist at 2, which means it's going to be a sharp cusp, because I believe in the question it does tell us, and I didn't copy the question, I apologize, it says it's a continuous function from 0 to 4. So from 0 to 1, let's take a look at the second derivative. It's increasing in a concave down fashion because the second derivative is negative. So that means going from x equals 0 to x equals 1, it's increasing in a concave down fashion. So it's going to look something like this. And then at 1, the derivative is 0, so there's a horizontal tangent there. And then it's going to be increasing in a concave up fashion. So it's going to be increasing in a concave up fashion till it hits that point. The derivative doesn't exist, so that means it's a sharp corner. And now it is decreasing because f prime is negative, and the second derivative is also negative from 2 to 3, so it's decreasing in a concave down fashion. So it's going to look something like that. And then from 3 to 4, it's negative, meaning it's below the x-axis. It's decreasing, and the second derivative is positive, so it's decreasing in a concave up fashion, looking something like that. And there would be your sketch. So again, kind of a unique question, but again, you had to find the first, second derivative off of the table and apply it to drawing a sketch. Okay, in the last example here, we are given a chart and we're asked to identify at points A if the function, the derivative, and the second derivative is either positive, negative, or 0. So let's take a look. A, the function is below the x-axis, it's negative. If I drew a tangent line there, it would be positive, and it appears to be concave up, so the second derivative would be positive. Okay, so for B, it is below the x-axis. The slope of the tangent line is positive. And again, I would say that's probably an inflection point. So my inflection points I'm going to approximate to be there and about there. So my second derivative is going to be 0 at the inflection point. C, the function is 0. The slope of the tangent line is positive and it's concave down, so it's negative. D, the function is positive. The derivative is positive and it's concave down, so it's going to be negative. At E, the function is positive. If I drew a tangent line there, it would be horizontal, so the derivative is 0, and the second derivative is still negative. At f, the function is positive, the slope would be negative, and the concavity is negative. G is an inflection point. It's 0, the slope is negative, second derivative is 0. H is negative, the slope of the tangent line is negative, concavity is up, it's positive. I is negative, the tangent line would be horizontal, it's concave up. J is 0, the slope would be positive, and the second derivative is positive. And K is positive, the slope is positive, and the concavity is up, so its second derivative is also positive. So again, another application type question, being able to identify f, f prime, and f double prime off of a graph. Okay, there's a handout again for this section as well, so you'll get that handout in class, and if you have any questions, you can go back and watch the video again.